In this video, I'll be going over how to solve a linear approximation question. So first, let's read the question. Selected values of a derivative of the function g are given in the table above. It is known that g of 3 is equal to 17. What is the approximation for g of 3.2 found using the line tangent to the graph at g is equal to x of g at x is equal to 3? So since it's telling us it's found using the line tangent to the graph at x equals 3, we have to draw a tangent line. So let's just write that. Y minus y1 is equal to m x minus x1. Right. So now let's try to find what m is, or our slope. So for a tangent line, the m in this case would be the derivative of the function in respect to 3 for this case. And the reason we're using 3 is that it tells us it's using the tangent line to the graph of g at x equals 3. So we're using 3 to help us approximate 3.2. So now let's look for what is the derivative of g at x is equal to 3. So looking over at x is equal to 3, right now, we've got x is equal to 3. It is right now negative 1.2. So let's write that down. Negative 1.2 times x minus x1 is equal to y minus y1. So what is our y1 in this case? So in a tangent line, our y value is always going to be whatever number we're helping to approximate with, which in this case is 3, and just plugging it straight into the equation. And this question already does it for us, as it tells us g of 3 is equal to 17. So that is y minus 17 is equal to negative 1.2 x minus x1. So let's move over the 17. So we get negative 1.2 times x minus x1 plus 17. So now that we got that, let's solve for what the x minus x1 is. So our x value will be what we're trying to approximate for. We're trying to approximate for the 3.2, or what g of 3.2 is. So x would be 3.2. 3.2 minus the x1. The x1 is what we use to supplement, or we use to approximate with to get 3.2, which in this case we use 3 to help us find the approximation. So it's 3.2 minus 3, right? And multiply that by 1.2, and we add 17. Right. So now that we have that, let's try to break this up. So we got negative 1.2 times 0.2, right? Because 3.2 minus 3 is 0.2. And then we add 17. So if you plug this into our calculator, you should get a final value of 16.76. That's your final answer. So you just have to plug in this final part straight into your calculator, and you should get this value. Alright, let's do another problem. You might have seen this earlier in the video as I slid down a little bit, but it's fine. So in this problem, it's asking, the selected values of a derivative of the function g are given in the table above. It is known that g of 4 is equal to 12. What is the approximation for g of 4.2 found using the line tangent to the graph of g at x is equal to 4? Okay, so the same steps as the first equation, essentially. So let's first start off with our tangent line. So y minus y1 is equal to m x minus x1. So now that we have that, let's find our m, or the slope. So I'll give you some time to figure this out on your own. And make sure to pause the video, and then I'll go through it right after. Okay, so after you finish your set, or whatever you completed, let's go through it together. So let's find our m value, which is the slope. So for our m, we have to find out what we are supplementing with instead of the 4.2, or what are we replacing the 4.2 with. In this case, it says 4, as the line tangents to the graph of x at x is equal to 4. So what is g prime of 4? It says here 2.2. So we write 2.2, since g prime 4. So 2.2 times x minus x1 is equal to y minus y1. So now that we have that, let's look for our y value. So as we mentioned before, if you simply just plug in this case the 4, right into the equation, that is our y value. And since it's already given up here, where it says g of 4 is equal to 12, that means that our y value is 12, or y-intercept value, as of right now, is 4. So that's y minus 12 equal to 2.2 for x minus x1. Now, let's figure out what the x minus x1 is. So since we used 4 to help us approximate with 4.2, we write that off as our x1 value. And as our x value, it'll be 4.2, since that is what we're trying to find out. Like, we're trying to approximate for what g of 4.2 would be. Multiply that by 2.2. And let's move the 12 to the right side. So we're going to add 12. So this makes the equation 2.2 times 0.2 plus 12. Right. So now that we have that, and if you're wondering how I got 0.2, it's just 4.2 minus 4, giving us 0.2. So if we multiply this, right, as 2.2 times 0.2, and we add that by 12, we get a final answer of 12.44. So looking back at both equations, if let's say it told us that this function was concave up, right? If that was the case, that means that whatever number we got right here, concave up, is an underestimate, right? So it's under what the actual value is. If it said it was concave down, let's say, that means that it was an overestimate. So it was above what the value actually is for what g of 4.2 in this case would be. So thank you for watching this video. I hope this was helpful for you, and have a good day.